Okay, so so yesterday we did day 2, and now I guess we're gonna look into day 3 and see how we can solve that one. Just quickly set up everything. It's day 3, and add the input. It's input 3.1.txt, and we gotta add it here as well. So we got the day 3, just copy over day 1 since it's smaller. Day 3, so it's day 3, and edit it here, 3.1-t. So we will run day 3, part 1 with the test input, and now see what we have here. Centers the living presence, 2-dimensional grid of houses. He begins the living presence house, North Pole. Moves are exactly one house north, south, east, or west. He delivers another present, at least one present. Okay, let's quickly get our input. There's quite a lot of things to do. So basically, we've got a grid, so I think I'm just point 2D, hashable, let x double point, let y int. So I can use that if I need to. So we got the inputs string, that's all okay. Do we have some test cases? Let's just use this one first. So run part 2, just remove that one. Now we can have part 1. Okay, so start 2.2D00. A starting location, it always delivers at a starting location. Okay. So occur visited set of point 2D to occur. So basically a set is what we need, since then we would just get out which items he visited, and it doesn't matter how many houses were visited, so a set is quite suitable for that one. So let's say for char in input string and input. Okay, switch char. Okay, switch do we have? Let's just copy that over, it's easier than searching them on the keyboard sometimes. So it's case, that's V, would have been easy. We've got left and we've got right. Default do nothing. Okay, if we go up, in that case I just decrease x. So I say gotta learn spelling. I say cur is equal to 0.2D x cur.x minus 1, cur down is plus 1, left is x and y minus 1, and that one is +1, and now we're gonna print visited.count, and we actually need to insert cur. Let's see what happens. Cannot cur dot y dot y. What happens? 2. That's what we expected. Let's just test the square thing really quick. So we also have the other directions in it. 4. That's also what we've expected. So run it with our actual data. So what do we have? 1. That doesn't seem right. Get the input for 3. Okay, that seems more reasonable. Let's see. Yep. Got he creates a robot version of himself, RoboCenter, to deliver presents to him. Center and RoboCenter start at the same location, then take turns moving based on instructions from the elf. Not reading from the same script as the previous year. Okay, now I got it. So like the first instruction is center, then RoboCenter, so we just have 2. So we say, okay, we use part 2. And part 2 is basically center and robot. It's the same. So instead of having if clauses inside here the whole time, I just use the delta thing and say delta x is equal to -1, delta x is equal to 1, delta y is equal to -1, and delta y is equal to 1, and then we say if index modulo 2 equals 0, then we have center. We just say center equals to point to the xy of center.x plus delta x and center.y plus delta y. Let me say visited.insert center, and else we use robot.x, robot.y, insert robot, and we don't need that anymore. And let's see what actually happens if we run part 2 with our test data. We got 3. What did we expect? 3. Okay, now that one's a bit more sophisticated, since they actually visit 11 houses now. Also got 11. So I'm gonna run it for proper data. 2,360, and that's the right answer. So apparently that was easier than I thought. So basically it's just iterating over the instructions, and the important thing, or the thing that makes it quite easy, is having a set. And then you can just add to the set, and it doesn't matter how often you visit it. I thought maybe you would need a dictionary or something in the second part, where you then could maybe count where he went and then something to the algorithm changes, I don't know, but it was easier than I expected. So thanks for watching. See you on day 4.